Hey everybody, I've got something pretty cool I want to share with you today. Something from my from my tender teenage years. So this is a piece of artwork that I made when I was 17 years old. And it's actually really cool looking. You see this is this blue material here, and you see that this is a kind of a reflective metal. It's silvery, and I'm trying to catch the light just right, but you see the airplane is all silver looking and it's pretty neat. What is this? Well, if you saw the thumbnail and the title of the video, you know what this is. And you can see that this actually is a printed circuit board. You look on the back and there's the raw surface after the acid etched away the copper that was on there. You can see, hold it kind of, if I get it to the light right, you can see a pattern that's embedded in that, the manufacturer's logo. You can see the edge. This is fiberglass. So that's really what it is. When I was in high school, I took a lot of technical drawing courses. I was really into drafting, and I did like architecture and machinery design, stuff like that. So back in that day, I don't know about these days, but back then there was a guy who would work with industry and try to find jobs for high school kids in the afternoon in trades that they were learning in school. And it was through that process that I got a job working in a place that did technical drawing for the automotive trade, where we drew circuit diagrams. You know, when you see a schematic or something like that, we drew those by hand. And it was a pencil and on a drafting board, and all the little lettering on there, the description, that was all done by hand. And my boss would, of course, tell me my lettering stank, because it always did. I tried to do a better job, but in fact of life, my lettering sucks. Well, one day my boss came to me and said, "Hey, I'd like to see if I could get you in another part of the industry, give you some more exposure, more experience. How would you like to go work down the street at my friend's circuit board shop where they manufacture these things?" And I said, "Sure, absolutely." And worked out a deal where I would work 2 days a week. I would go to do my technical drawing and draw circuit diagrams. And then 2 days a week, I would go to this place that made circuit boards, where I would expose my tender young 17-year-old liver to all kinds of horrible chemicals. And I would breathe in those delightful bits of fiberglass in the air. And it was during those months when I was working in both places, I thought, you know, these processes are really interesting. I wonder if we could do some kind of a piece of artwork. I went to my bosses, both of them. I said, "Hey, what do you think if I made a drawing and we turned that into a printed circuit board like this?" And they both thought it was a really neat idea. In order to understand how this was made, I'm going to have to describe a little bit about how printed circuit boards would have been made in the 1970s. Today, it's a very computerized process. You can go into your computer and design a board with CAD software and send it off and have that, just upload it and have them make 100 boards for you for some really dirt cheap price. Back then, it wasn't that way. It was all done manual through optical, mechanical processes. And in order to understand how we made this, I'm just going to have to give you a little peek into how printed circuit boards would have been made at that time. So maybe I'll probably bore people to tears, but skip ahead, I guess, if you want to see close-ups of this or something like that. In any case, I'm just going to start by describing how a hobbyist would have made a printed circuit board in 1975. So if you were a hobbyist in 1975, you would have gone to Radio Shack, you would have bought this little kit, and it would have had some copper-clad boards they're made out of fiberglass with copper on one side, and you would have some little pieces of dry transfer, little rub-on kind of little stickery things, and maybe a roll of pinstriping tape. And what you would do is you would go and you would lay this stuff all out on your board and rub it on in the way that you wanted your board to look. Then you would dunk the board into a little bath of ferric chloride, an acid that will eat all the copper. And you wait and wait and look at it and wait and agitate it and keep looking at it. And eventually all the copper that was in the places between where you put your little stickers will get eaten away. And you wash all the stickers off, and there you go. You've got a board that has copper lines on it, and you can drill the holes, mount your parts. And of course you made a mistake and you got to do the whole thing all over again. Well, what if you were a more advanced hobbyist and you wanted to make a bunch of these boards? You wouldn't have to make them by hand like that, one and the other. Or maybe you wanted to copy a board from a magazine like Popular Electronics. Well, they had you covered. A serious hobbyist in the mid-1970s would have ordered a kit. Here's an article in Popular Electronics magazine in September of 1972 that explains the process. And I'll just cover it in broad strokes. You start with a master of what you want your board to look like. And let's just assume you are doing a project from the magazine from 1978, and there was a circuit board diagram in the magazine. You take that to work, you make a photocopy onto transparency film, clear plastic, and you bring that home. So then you take that clear plastic and you sandwich it with a piece of what they referred to as reversing film. And you expose that to light for a few minutes and then develop the reversing film with the developer they give you. Very simple process. And now you end up with a negative of the board with black all over the big spaces and clear wherever you want your copper to be. Then you take that negative and you lay it on top of one of the copper-clad boards with an emulsion on the board. You would buy these from them. It would just be a printed circuit board, blank, that had the film emulsion already on it. And you would lay this mask that you had just made on top of that board, the negative mask, and expose that to the light. And once that was done, everything that the light touched would be hardened, and everything the light didn't touch, which was the space between the lines, would be soft. And you could just rinse that off during the development process. And now what you have is a copper board that has a mask covering everything that you want to keep. You've essentially created the same thing you did when you used the tape. So take that, put it in the acid, stir it, get nervous thinking you made a mistake, look at it, whatever, and eventually take it out, wash off the remaining stuff, and now you've got a board just like the cheap and cheerful use rub-on transfers process. So the process we did in industry was very similar to that, with an added twist. And when you look at this, say, why is it silver? And that's the twist. In fact, if I show you images of circuit boards from the time, like here's a image of a Commodore 64 motherboard, and here's an Apple II motherboard, and you'll see they have solder covering all the traces. All the lines are not copper, but they're silver, and they're covered with solder. And you might think, well, they're using wave soldering, of course. Well, they did use wave soldering, but the wave soldering will be on the bottom, not on the top. Why was there solder on the top? And so here's PDP-11 board. Same thing. You can see all those traces, which should be copper. They're not. They're actually covered in solder. And that's the secret. That's why this plane is silver. So the way that they did it was when a design came to our printed circuit shop, it would come in the form of that negative that I showed you. Then we would take that and expose it again and make a positive print. It's the opposite. And then we would take the positive print and use that as the mask on the printed circuit board. We would put the same film on the board, and it looked kind of like the stuff that, you see a car with tints on the windows. It was like that stuff. And came on a roll and put it on the board, and you put this mask on it, but we used a positive mask, and we exposed it to UV light. And once we developed it and washed off all the unexposed parts, you would end up with a negative mask on the board. covering all the spaces between the lines, exposing the lines. And it sounds backwards because if you put it in acid at this point, it would just eat away all the copper you wanted. So, but what we did was different. We would actually take and put a clamp on the corner and dip it in a plating line, in a plating bath that would electroplate everything that was exposed with solder. You can see where this is going now. Then when we washed off all the solvent, you would end up with a copper board that had all the lines in solder. And we put it in an acid that would only eat the copper. It would not touch the solder. And then for the finishing touch, after everything was done, we would take the boards and put them in an oven that would melt the solder, and it would cause it to flow in all the nooks and crannies and give it a really shiny finish. Now you see how this was made. It's really a spiffy process. What I didn't describe was how the artwork was done. So the very first thing I did was I took a book from our high school library that had, it was a World War II book, and there was a picture in the front cover of a Dauntless dive bomber. So I took that picture and I sketched the plane in pencil on regular drawing paper. And then I put a piece of Mylar on top of that and used what we called film pencils. I don't know what they are, but they're like really dense pencil that we used in drafting. And I used that to do the actual drawing that was ready for the camera, and with shading and things like that. Once that was done, we took it to the print shop that the drafting place I worked at used. And the print shop did what is called a halftone. The way a halftone works is something that involves a mask that gets inserted in the light path, and it's got little holes in it. And they use a special emulsion that is very sensitive to contrast and either is black or white. Nothing in between. And by using a combination of that mask and the special emulsion, they get an image that is made out of dots that are proportional in size to the density of ink that you want there. That's how newspapers are printed. That's how books, the images in books are done, just by making dots that vary in size. And it was all done optically. There's no computers in this, no Photoshop, none of that. And so when you look really close at this, you'll see that this image is actually made of little tiny dots, made through that process that I just described. This one almost didn't survive the generations. I made this 39 years ago. Why do I still have it today? How do I still have it? It should have been lost in the great purge of all of my stuff when I went in the Navy. I got rid of everything. For whatever reason, I had this desire to just cut off everything in my life before the Navy, and all I went there with was a shaving kit and a comb. So how did this one survive? Well, it turns out we printed a whole bunch of these. We made various designs with various combinations. We had some that were done with the plane being open, with like a negative of this, and copper. There was one where we did the board copper and we left the plane in the solder. And I thought that would look really cool. It just didn't have the contrast. It didn't look nearly as neat as I thought it would. And there was one we did on black printed circuit board stock. I special ordered that on my hard-earned money. And we did the background in copper and the plane was black. That looked really smart. And my woodshop teacher helped me make a frame for it. It looked really neat, and I gave that one away like a fool. So that one's gone, and all the others, I don't know where they went. This was there was a company in town, it was called Company X. Their trademark was blue printed circuit boards. And as we were doing this, I said, you know, wouldn't it be cool if we did this on blue? Can we use some of the circuit board stock that we use for Company X? And my boss said, yeah, let's try that out. Let's see what it looks like. And we did one in blue, and that's this one. And I thought this was probably the neatest looking of them all. I'm glad this is the one that survived. How did this one survive? It turns out, maybe a couple months ago, I was looking in some old photos, and I saw a picture from my brother's house that was taken in maybe 1987. And this was sitting on the shelf. There it is. That's how it survived. And unfortunately, my brother passed away. all this came back to me, and that's why it's still here. And I'm really happy I still have it because it's a good memory, and it's something that was a fun project and looks kind of neat. So that gives a neat insight into the way printed circuit boards were made back in the Stone Age, when we would tie up our dinosaur to the hitching post on our way into school. So that's all I got for you today. Isn't that cool? Thank you for watching.